The Association of American Medical Colleges is pleased to welcome you to today's webinar, the overview of the National Academies of Sciences, Engineering, and Medicine and its 2018 reports. My name is Sandy, and it's my pleasure to be the facilitator for today's event. I'd like to formally welcome the participants who are joining us today. Please note that today's call is being recorded and will be available online in 3 to 5 business days. All participant phone lines will be muted during this broadcast. If you experience technical difficulties with the web portion of today's program, please email aamc@compartners.com or send a message in the chat box. If you are listening to the program over the phone and you need assistance at any time, please press *0 and an operator will assist you. This presentation will last up to 60 minutes and will include question and answer opportunities during the webinar and at the end. You may submit a question at any time by typing into the chat box at the lower left corner of your screen and clicking on the send button. I'd like to direct your attention to the links box on the left side of your screen where the presentation slides are located for you to view, save, or print. Simply click on the link and a separate web browser window will open. This will not interfere with your viewing of the program. It's now my pleasure to introduce Amanda Field, Science Policy Specialist at AAMC. Amanda?
Good afternoon. Thank you for the introduction, Sandy. And as you said, my name is Amanda Field, and I work in the Scientific Affairs Unit at AAMC, in which my team and I focus on improving and communicating research and research training policy issues that affect our member academic medical institutions. The AAMC is excited to be partnering with FASEB and the National Academies to present this webinar series on several academies' 2018 reports that are relevant to the biomedical community, which you see pictured here. Those are the Graduate STEM Education for the 21st Century, Open Science by Design, Breaking Through the Next Generation of Biomedical and Behavioral Sciences Researchers, the Integration of the Humanities and Arts with Sciences, Engineering and Medicine and Higher Education, Branches from the Same Tree, and last, Sexual Harassment of Women, Climate, Culture, and Consequences in Academic Science, Engineering, and Medicine. The goal of the series is to not only relay the key findings and recommendations of the reports, but to provide the community with a chance to interact and discuss their concerns over and efforts to implement these recommendations at their own institutions. This first webinar will start with an introduction to the National Academies themselves, as well as an overview of each of the reports provided by the National Academies study directors of each report. The subsequent webinars, which the study directors will again be speaking for, will focus on the individual reports. During these webinars, there will be an open chat box that the audience can use to communicate with us and with each other, and there will be several opportunities to provide your thoughts, concerns, questions, and tips on implementing the recommendations of that report. For this first webinar, we are interested in hearing back from you on any questions you have about the reports and what you hope to learn during the in-depth webinars later in the series. But before we get started on the reports, I'd like to introduce Alex Hellman, an Associate Program Officer at the National Academies, who works with the Committee on Women in Science and Engineering and Medicine. She is going to provide an introduction to the National Academies and what goes into publishing their reports.
Thank you, Amanda. Hi, everyone. Like Amanda said, I am Alex Hellman. I'm Associate Program Officer with the Committee on Women in Science, Engineering, and Medicine at the National Academies. And it's funny, before we started this webinar, we were all sitting around the table talking about how oftentimes people don't know exactly what the National Academies are and what we do. So I thought this is a good way to introduce everyone to sort of what we do here in DC and the work we provide. So I'm going to start by introducing a little video. For the sake of time, we've cut it a bit short. So the introduction, there's a woman talking, you'll hear her start, and that is Dr. Marcia McNutt, who is the president of the National Academy of Sciences. She is our first woman president of the National Academy of Sciences. And so you'll see her throughout the video, but just as an FYI, that's who's speaking.
The National Academy was founded during the darkest days of the Civil War. President Abraham Lincoln and Congress needed scientists and engineers on their side to both win the war and to secure the future economic prosperity and health of the young nation.
These are the most celebrated scientists within every scientific field, who are tasked with only one thing: to advise the executive branch and Congress of all ways the progress of science can impact policy and law for the betterment of the country. That's a gift to these United States of America.
Over the history of the National Academies of Sciences, Engineering, and Medicine, we're responsible for hundreds of reports every year that have touched so many parts of our lives. From the establishment of the National Park Service, to repairs to the Hubble telescope, or the fact that so many childhood diseases have been all but eradicated. The output of the National Academies is staggering.
Okay, great. So like the video said, the National Academy of Sciences was started by Abraham Lincoln in 1863 when he signed a congressional charter that officially forms the National Academy of Sciences. And the quote seen here is in our charter: "The Academy shall, whenever called upon by any department of the government, investigate, examine, and report upon any subject of science or art." And so the National Academy of Sciences has been around since 1863, but as I'll talk about in a bit, we actually have expanded to include the National Research Council, which was formed in 1916, the National Academy of Engineering in 1964, and the National Academy of Medicine, which was established in 1970 originally as the Institute of Medicine, and then formally became the National Academy of Medicine in 2015. So the National Academy of Sciences is, we are a private, nonprofit, self-selecting membership of organizations of eminent scientists, engineers, and medical professionals. And so I think before I came to work at the National Academies, my understanding of the National Academies was as a membership organization. And we were started originally to provide independent, objective advice to the nation on matters related to science and technology, and provide advice to the government. And originally this was done by solely by our elected members. However, as science began to play sort of a more increasing role in national priorities and in public affairs, particularly around World War I, the limited membership of the academies, which was only about 150 people at that time, just couldn't keep up with the volume of requests we were receiving for advice. So at that time, the National Academy of Sciences expanded to include the National Research Council, and that was in 1916 at the request of President Wilson, in order to recruit specialists from the larger scientific and technical communities to participate in the work. So we have people who are not necessarily members participating in our studies and in the work that we do. And so under the National Research Council, we established the National Academy of Engineering in 1964. And then, like I said, the National Academy of Medicine in 1970 as the Institute of Medicine. So we have National Academy of Sciences has about 2,100 members. The National Academy of Engineering has about 2,000. And the National Academy of Medicine has about 1,600. And all three organizations also elect foreign associates from nations around the world to participate in our processes and our studies. And so we are a private nonprofit, so we are not a government agency, we are not the National Science Foundation, and we do not participate in advocacy, so we don't advocate. We give unbiased advice based on what our experts agree on as consensus. So we are different from, say, an organization like AAAS, which is more of an advocacy organization. And we advise when called upon, so when a study is needed to be done, and sometimes our studies are congressionally mandated, we sort of answer these questions of the need of the nation. So our process is sort of this: we avoid the shoot first and ask questions later approach to policymaking. So rather than that, we take time with our studies. Our studies do take a great deal of time, but we sort of come with the approach of, giving advice first and then creating policy based on what we find is the best scientific evidence to make such policies. Our scientists who are elected to NAS are elected by their peers, and almost 500 members of the NAS have won Nobel Prize. And we also have a journal called the Proceedings of the National Academy of Sciences, which is a fairly prestigious journal, which this publishes into original research. So this is a sort of a busy slide, but just to outline where the reports that we are talking about today and over the course of this webinar series lay within the sort of National Academy's framework. Up top, we have National Academy of Engineering, National Academy of Sciences, National Academy of Medicine, and then all those flow into the Executive Office, which is where NRC sits. And in this, we have three units. We have administrative units, our executive units, and then relevant states, where we have our individual program units. And so there's 7 program units, and all of the reports that are talked about today fall within the Policy and Global Affairs Division, which is led by, recently taken over by Von Tarikian. So like I said, all of the reports we're going to talk about today lie within Policy and Global Affairs. And so our mission is to improve public policy, understanding, and education in matters of science and technology and health with regard to national strategies and resources, global affairs, workforce, and the economy. So we sort of approach our work with sort of a global mindset. We work across disciplines and issue areas concerned with the standing of U.S. research around the world. So a lot of the different divisions within the national academies are very specific to, we have one that works on transportation and another on health and medicine. We are concerned with the standing of U.S. research as a whole, and not just in the U.S., but in the world. And so there are 15 units within the Policy and Global Affairs Division, and 3 of them, which all oversee the reports that are going to be talked about during the webinar series, include the Board of Higher Education and Workforce, or known as BHU, the Board on Research Data and Information, and lastly, the Committee on Women in Science, Engineering, and Medicine. So the Academy is, as staff, we have about 1,100 employees. All of our studies that we put out are the work of volunteers, and so we have 6,000 volunteer committee members each year, which is kind of an unbelievable amount, and given the people that we get to serve on our committees, it's really, these studies could not be done, and we could not do it to the ability that we do without all of our volunteers who devote countless hours to make these projects happen. We receive over $250 million in annual program activities, mostly sponsored by federal agencies or private foundations. And so we have several ways of operating. The most common and the ones we're going to talk about today all fall under the realm of a consensus study, which I'll talk about in a minute. However, we also hold convening activities such as workshops and roundtables. We also have operational programs such as fellowships. So actually both Amanda and myself were previous fellows, Merzion Fellows at the National Academies. We also have a Ford Fellows program, which sponsors underrepresented minorities in scientific fields. And we represent the U.S. internationally through the Inter-Academy Partnership. We give awards to scientists every year, and we have a journal, which I talked about, the Proceedings of the National Academy of Sciences. So overall, we're pretty busy over there. We produce about over 200 reports per year, and all of these are freely available online. So on the National Academy, the NAP website, so it's nap.edu, I believe, you can download all of our reports for free. And there's also you can also purchase a print version if that's something you would prefer. sort of the bread and butter of the National Academies is what I talked about, these consensus reports. This picture here is Einstein, which is outside of our National Academy of Sciences building. He's quite popular because he's one of the few statues in DC that you can pose with and touch. And so if anyone is ever in DC and would like to visit the National Academy of Sciences, it's a really beautiful building. So the consensus study process, most projects originate from either congressional mandates or from internal discussion. So either the Congress, deems that they need the scientific advice and congressionally mandates a study, or we discuss among our funders or within agencies about a study that people feel really, really need to be done to address sort of a need base. And so we define a study by developing and approving a statement of task. And so the statement of task is sent to all of our committee members, and we have to make sure through the time we're writing the report, through all the way through review, that we're sticking to the statement of task and that we're sticking within this scope. If not, it does not go through the review process if we go outside of the statement of task. So this is very key. And these are all published on our web pages. So when you for all of our reports, we have a web page where you can see the statement of task, read it, and that's the only part of the process actually that is sort of public knowledge before the report is released. So you can see sort of what we plan to do with the study or what the task will outline. But the actual convenings of our meetings are under embargo. So we end up putting together a committee and based on expertise of the committee, and so we really want to balance both expertise. We want to balance of perspectives, diverse demographics, both across race and ethnicity, geography, age, and all sorts of different axes there. Conflict of interest screenings, and all of these committees go up for a public comment period. So if you actually Google National Academy's current projects, you can find a link to all of our current projects that are underway, and if you are interested, can see our committees that we've nominated and are open for a public comment period. So during the process of a consensus report, we hold committee meetings, some of which are open to the public, some of which are closed door to allow deliberations, where we gather information, and eventually the committee themselves drafts this report. So really all of our reports are drafted by our volunteers, which are just a group of experts that are kind enough to volunteer their time due to a need that they see as pressing. And so after we write a report, it goes through a very rigorous review process. I always laugh because in academia, it always seemed like the 3 reviewers was crazy, and for our reports, we often have 15 to 20 reviewers at times, which is a lot. And then at the end, once the report has gone through review, the report is released. And for most of our studies, we're trying to do a good job of disseminating the report to make sure it reaches a large audience, which is why we're here today to talk to AAMC.
Thank you, Alex. We have just a couple of questions before we move to the next part of our webinar. So we're wondering, how are the elected members, how are they selected and elected?
So each academy, so the National Academy of Sciences, National Academy of Engineering, and National Academy of Medicine, each has their own sort of process, and so they have usually a nominating board or committee within each academy that sort of nominates names, and then they are voted on by the membership body of each academy, and then each year at their annual meeting are elected as based upon the votes to each academy that they're nominated for.
Okay, thank you. It sounds like you provide a lot of important recommendations in your reports. How do these recommendations work? Is the National Academies, are they telling Congress what to do, or how does that work?
No, we don't tell Congress what to do, but we do provide advice and recommendations to key stakeholders, so people that we see as key targets for and audiences for our reports. We can provide recommendations and say this is what we see based on the scientific evidence. This is something we advise moving forward.
All right, I think that's all the questions for now, so go ahead.
Well, thank you, Alex. That was very interesting. And for all of us who didn't know what the academies did and how they came about, it's very interesting. Thank you. So the National Academies, along with AAMC and FACET, are excited to bring you the following webinar series to give you, the community, an opportunity to ask questions concerning the Academy's in-depth reports and most importantly, discuss how to implement their findings. My name is Dr. Anna Roberts-Pilgrim, and I am the Science Policy Fellow at the Federation of American Societies for Experimental Biology, also known as FASEB, where we advance health and well-being by promoting research and education in biological and biomedical sciences through collaborative advocacy and service to our societies and their members. I'm also pleased to introduce our webinar speakers. Lane Scherer, Program Officer on the Board of Higher Education and Workforce at the National Academies, who will be presenting the report, Graduate STEM Education for the 21st Century. We also have Tom Arison, the Program Director for Development, Security, and Operation, who will present the report on Open Science by Design, Realizing a Vision for the 21st Century Research, followed by Dr. Lyda Benenson, Program Officer for the Board of Higher Education and Workforce at the National Academies, who will be presenting the report, The Next Generation of Biomedical and Behavioral Sciences Researchers, Breaking Through. Dr. Ashley Baer, Senior Program Officer on the Committee of Women in Sciences, Engineering, and Medicine. She will be presenting on the National Academies report, The Integration of the Humanities and Arts with Sciences, Engineering, and Medicine in Higher Education, Branches from the Same Tree. And finally, Dr. Fraser Benyei, Senior Program Officer for the Committee on Women in Science, Engineering, and Medicine, and presenting on the report on Sexual Harassment of Women, Climate, Culture, and Consequences in the Academic Sciences, Engineering, and Medicine. I would like to thank each of you for all your work on each of these reports and for teaming up with AAMC and FASEB to bring these reports to our audiences. So let's jump into our first report overview by Lane Scherer on grad STEM education for the 21st century.
Hello, everyone. This is Lane Scherer. I served as the study director for the Graduate STEM Education for the 21st Century report. And one of the great things when you work at the National Academies or around us is your lung capacity ends up growing because the titles of our reports are such that you get to practice holding your breath for a little while. But anyways, getting into our first report for the day, the Committee on Graduate STEM Education for the 21st Century was a report that was really meant to serve as an update to a 1995 report at the National Academies. And the National Science Foundation, the Institute for Education Sciences, the Burroughs Wellcome Fund, and the Spencer Foundation thought it would be a good idea, given sort of the big shifts in context in the conduct of research, the world of work, and sort of the enterprise of higher education, that it would be a good idea to return to see, you know, what has changed in the 20-plus years since the 1995 report came out. And so going through, and as Alex mentioned, you know, the committee had a statement of tasks, and so the big overarching idea through all of these points that are listed and coming through on the screen is, what is the state of graduate STEM education for the 21st century? And the statement of tasks, which is listed here, provides an outline of all the things that the committee was asked to do. And so in the end, when we get to the reviewers, they were asked, you know, did the committee meet muster and address all of these issues? And so as you can see here, it's a pretty wide range. We're looking at master's and PhD, science, technology, engineering, and mathematics. And for the sciences, that does include social studies and the education sciences. Given our support from the Department of Education, they were deeply interested in that. And one of the great things about this committee, and Alex might have alluded to this, you know, we bring in these volunteers, we get great members, and we ask them to sort of lay out their conflicts of interest and biases. So I'll lay out for some of my own just as we're getting started, and hopefully when you tune into our December 17th webinar, we'll be able to get more in depth about the, you know, what went into the report. But I mean, University of Michigan graduates, you can see the colors on the screen reflect that, but I will say I'm biased in that I think we had a great committee that worked on this report. We had great sponsors, and even though the statement of tasks was very large, I think it gave everyone the bandwidth to really be able to dive into what is the state of graduate education, what is the future, and how do we help shift the system of graduate education as it is today to meet the needs of future learners. And then the funders are down there, and then one of the things that came up, actually one of our funders mentioned this in our first meeting, is what makes this report different. And so we wanted to go back and look over sort of the 20-some years of reports and make sure that we understood sort of the trajectory of where all the stakeholders had been, what recommendations had come out before. And so our report really takes a systems approach, and here are a number of things that we outline in the report that makes it a bit unique. So we, in addition to sort of making recommendations, there's a vision of a student-centric system of graduate STEM education that promotes diversity, equitable and inclusive environments, and really takes into attention the needs of all learners. And so that is, ensuring that people from all backgrounds, if they're coming, straight through from undergrad, if they're returning to school, whatever their needs are, that the system should be able to meet them there. There are also, in addition to that vision, there are some core competencies that talk about what master's and PhD students should earn over the course of their studies, and then really gets into this issue of culture change. And so thinking about what does it mean for a system this big that is fairly diffuse, where each sort of institution is its own entity, its own kingdom made of several different pieces and leaders and different incentive structures. What does it mean to make change at a systems level? It requires change at every single level. It requires faculty to change, departments to change, chairs to change, provosts and presidents and anyone at the lead to take a hold. It requires institutions to work together for change. There are several initiatives that have come out where sort of coalitions of different institutions are working together on some of these issues to sort of almost make a grassroots efforts to promote these things going forward. And then, of course, we have federal funders, we have our wonderful professional societies, and then students themselves also have, I wouldn't say power in the system, but they have a role to play in making sure that the needs that would be helpful for them to reach their professional educational goals are articulated and to push the system to move in that direction. And then finally, we talk about getting there. So we break down in the report for each stakeholder sort of which specific actions are needed to make a difference. Just really quickly to make sure, the key recommendations I don't think will be new to most folks. Let's go back one. Got a little excited. Who have been familiar with this. And so it's about, what can departments be doing to make sure the curriculum and the offerings at the programmatic level are useful to students, what sort of additional extracurricular and professional development activities can help students really generate the skills that they need to be successful in whatever career they're interested in. And then finally, how can employers provide guidance and potentially financial support, looking at sort of the shift in models of how we've invested in workforce development. Employers used to invest a ton of money in their employees, and so how can we get back to that? And so hopefully, again, you'll hear more. This is just a little appetizer going forward, and then there are a number of things about, what can be done to help the student experience and make sure that students are feeling included and safe, mentally and emotionally in their studies. So we are looking to take questions now in what your interests are, and then, hopefully with any feedback that we get now or, further down the road, we can integrate that into the December 17th webinar.
Thank you, Lane. I just would like to say, as Lane just said, we're really interested in your questions. As a reminder, you can put them in the chat box in the bottom left of your screen at any time throughout the presentation. For any report, we're really interested in hearing what you are interested in learning about. So even if you have a thought later, please add it in and we will get to it at the end, or if not, at least we have that knowledge for our future webinars. So we have one question before we move to the next. Where do you think institutions should start in trying to create more professional development opportunities?
So I think that's a great question, and one of the issues that the committee confronted while working on the statement of tasks is the fact that all institutions are starting at a different point. And so where they need to invest really depends on where their investments have been previously. And so it could have been in career development, maybe in helping students work towards becoming faculty members. It really, doing an assessment of where they are now and then what their students want, and then figuring out the gaps to meet it. I think it's going to really depend on the context of each institution, but I think kind of figuring out locally what is desired and what is already being offered is a great first step.
Thank you very much. Again, any questions you come up with as we go on, please do not hesitate to add them in. I'd like to introduce our next speaker, Tom Arison, who is the Program Director at the, on the Board of Development, Security, and Cooperation, and he will be speaking to us about the report, Open Science by Design.
Good afternoon, everyone. Thanks for...
Go back to Chrome.
Okay. Sorry.
Sorry, technical difficulties. 1 second.
Quick.
All right.
Okay. Thanks, everyone who's listening. Thanks to AAMC and FASEB for providing this opportunity. And this report is titled Open Science by Design, Realizing a Vision for 21st Century Research. It was completed and released earlier this year in July. And for the purposes of this study, open science is defined as having open access to articles and other report-type products of research, to the underlying data that supports those research conclusions, and to the methods, including source code, that are involved in producing the research results. So this study was undertaken by the Board on Research Data and Information, a committee which put together the committee and oversaw the work. Is it not advancing?
Not advancing. Oh.
Okay, there's one. Maybe I have to wait for each one. So the task was to identify and address the challenges of broadening access to scientific research and develop recommendations aimed at moving toward open science as the default for scientific research results. So the study and the committee didn't have to prove that open science was a superior approach. It was sort of assumed that it is, but the committee did consider and present evidence of the utility and effectiveness of open practices and open approaches to research. The authoring committee, we had 10 members from a variety of different disciplines, chaired by Alexa McCrae of Harvard Medical School. The sponsors were the single sponsor, the Laura and John Arnold Foundation, which is based in Texas. So the key themes and findings that open science delivers a number of benefits, including faster, more inclusive, more reliable science, and some examples of that from it enables citizen science, open data and open results allows stakeholders, non-research stakeholders to contribute to research and to affect research processes in a way so that it delivers benefits to them. Having data and methods available also enables work to be checked so that research results are more reliable. And having complete information about research studies available speeds the process of building on those results. There are also barriers to openness, including the incentives faced by most researchers who see openness isn't generally rewarded, and in fact, many researchers see pursuing kind of research in closed ways as being more beneficial to their career. There are costs involved in openness, such as the infrastructure needs related to open data. That's an example. And also the current structure of the scholarly communications market, in which most articles are published in non-open journals, is also a barrier. Today, I think, and the committee concluded that we're at an inflection point where approaches enabled by machine learning and artificial intelligence to look at many different data sets and many different results to guide future research is poised to enable a new a new approach and new paradigm in research so that openness will become even more valuable. The committee came up with a framework called Open Science by Design, which consists of the principles and practices that foster openness throughout the research life cycle. And that many of the conclusions, recommendations, and subject matter of the report are explained in terms of this Open Science by Design framework. And common to the other reports that we're discussing here in this webinar series, the making progress will require persistent coordinated actions on the part of the entire research enterprise and its stakeholders. So the topics that we're talking about and that we've been taking on and published reports on this year kind of are complex, they're big problems, they're big issues that are going to take time and patience and involvement from everybody to move forward on. Just a couple of the key recommendations. We had findings, 5 recommendations, and then specific implementation items under those. And I'll just kind of skim over these. The first one, because incentives are such a barrier to openness, building a supportive culture and instituting rewards for openness was seen by the committee as kind of a major, probably the most important task going forward. And related to that is implementing training. There is some open science training. Organizations such as the Center for Open Science and the BITS organization at Berkeley on that focus on the social sciences, they do provide some training and tools for open science, but the committee recommended that that be expanded into other areas and fields. Another task is to ensure long-term preservation and stewardship, particularly of data, which there's a wide range of whether data should be saved at all and how to do that and what infrastructure is needed to do that. Facilitating data discovery, reuse, and reproducibility is also important. Openness is not probably enough to make, and we talk about in the report, the FAIR data principles: findable, accessible, interoperable, and reusable, as that really enables data to be used and to be a resource. And finally, develop new approaches to fostering open science by design. Most of those ideas in that section of recommendations and implementation actions deals with the scholarly communications market and developing new publishing venues and funder strategies and institutional strategies so that more articles are published in open settings. And the recent announcement of Plan S by the European Union is relevant to that. This is kind of a hot topic that people are working on actively. So that's what I have.
Tom, thank you for your great synopsis of the Open Science by Design report. I'd like to take a moment again to invite our attendees to submit questions and items of interest that you would like to see discussed more during the full-length webinar in January. We have a question. Did the committee have any concerns about protecting data that might be private, such as patient information?
Right, exactly. The report recognizes, in addition to the barriers that I specifically discussed, that there are, with particular types of data, in health and medical field, there's patient privacy data. That's also true in other fields. There's privacy issues. There are national security issues with some sets of data. There's also some proprietary restrictions on data in certain research settings and under certain topics. The And there is a discussion in the report about specifically related to privacy and how that's an advancing research field about how you can use data, de-identifying, and we find out sometimes de-identifying doesn't work, but that is a continuing challenge that needs to be overcome.
Thank you, Tom. I think it'll be very interesting in light of the Plan F information coming out, how this report is implemented. Okay, we will now shift our focus to Dr. Lyda Benenson, who will talk about our next report entitled The Next Generation of Biomedical and Behavioral Science Researchers, Breaking Through, which we will hear in greater detail during our webinar on February 19th, 2019. Dr. Benenson is the Reports Program Director on the Board of Higher Education and Workforce. Dr. Benenson.
Thank you so much. And also thank you to the AAMC and to FASEB for hosting us. This is really exciting. We've worked very hard on these reports, and we really want to help raise the awareness about these recommendations and their impact as well. So before I get started, I do want to let you know that before my life at the National Academies, I myself was a biomedical and behavioral researcher, and I worked up through my postdoc, and then following my postdoc is when I came to Washington, D.C. to work on science policy. But that's just to say that I was excited to dive into this project, and I had seen a lot of the struggles that are facing the early career biomedical, behavioral, and clinical researchers, and it was wonderful to be able to work on this. This is one of the studies that was actually congressionally mandated. And while I have a slide here that's showcasing that this was spearheaded by Senator Tammy Baldwin of Wisconsin, who is a Democrat, it was actually co-sponsored by Susan Collins of Maine. So this had bipartisan support in the Senate. And this made it extremely exciting because the biomedical workforce, particularly the early career workforce, has been an area of concern for well over 20 years. In fact, we have reports back from 1994 that are articulating the concerns about our biomedical research and whether or not there's an imbalance between the number of people who are trained to do fantastic research in this country and the number of research positions that are available for them to move into. So we felt really fortunate that this national priority issue actually grabbed the attention of the Senate and that we had a platform with which to really move forward and create strong and bold recommendations. So this was a 17-person committee. It was a phenomenal committee. It was very diverse and chaired by Mr. Ron Daniels, president of Johns Hopkins University. And we were very lucky to have him involved in this project. And the committee's task actually came straight from the legislation that was developed in 2016. And specifically, it was to examine what can we do as a nation to ensure the successful launch and the sustainment of biomedical and behavioral researchers, and specifically trying to look at those who are doing research that's related to what the NIH sponsors. So we know that the NSF sponsors quite a lot of research. We know that DARPA, even Department of Energy, sponsors biomedical and behavioral research. But this statement of task taken from the legislation really did specify, make sure you cover all of the areas of science that are covered by NIH. And so NIH was the main funder of this project, but we were also very fortunate to have support from Bloomberg Philanthropies as well. So I feel extremely excited that I have the month of February, or a webinar in February, to talk with you about this. This was a very expansive project, and I really don't want to get too deep into the recommendations because the recommendations that the 17-person committee made were really sweeping recommendations. The bulk of those recommendations were targeted at NIH as well as research institutions themselves. But I thought I would cover just a couple of things that might be interesting to a AAMC audience. So the committee, from the very beginning of their work, recognized that early career biomedical researchers at this moment are a very vulnerable population And the population, the subpopulation that's one of the most vulnerable within that are those of clinician scientists. How you define vulnerability is different across different axes, but just as a starting point, and I will share a lot more data with you if you're interested in February, but if you look at the age at which an investigator receives their first NIH R01 award, which is kind of the big award that kicks off your research career, on average for a typical PhD, that has risen from about age 35 in the 90s to presently 43. So when you're talking with postdoctoral researchers about when they're going to kickstart their career, their independence, it sounds a lot like they don't get to be independent until their early 40s. And there's not many other careers where an apprenticeship often takes that long. But then if you look deeper into the data, you'll see that researchers who have an MD, their average age for obtaining their first R01 is 47 years old. So the committee realized that this is absolutely out of balance, and so they worked really hard thinking about these sorts of data, these sorts of vulnerabilities, the mix of ages or the proportions of ages that are supported by NIH, and noting that it's becoming increasingly older. And so what they did was try to make a bunch of recommendations that realized that the current system of research is incredibly complex, and you can't just fix one side. Most importantly, you can't point the finger at NIH. While NIH is incredibly important in incentivizing change in the structure, what we've seen is we've looked at those last 20 years of reports. Many of those recommendations have been targeted at research institutions, and there's very sporadic implementation of those recommendations. So the overarching big recommendation that the committee made was to establish a multi-stakeholder council in order to create a system of accountability so that we can actually work in a way where we improve the system in a coordinated and systemic fashion. And I'm happy to talk more about that in February. Our next recommendation was about, there we go, the importance of collecting data, especially about the postdoctoral experience, with which we have very, very little national data. And it's very hard to make programmatic changes if you don't have solid evidence with which to base that recommendation on. The next recommendation was, well, not one, but there was a series of recommendations about NIH trying to increase the number of fellowships that were available to try to find a way to shift postdocs off of their principal investigators' research project grants and onto their own independent awards. And then one of the really cool ideas that the committee had was to actually have NIH fund a sort of program that would support innovation in biomedical and behavioral workforce issues. And so with that, I really look forward to the opportunity to engage with you. I encourage you to take a look at the report. There's a lot of data in the second chapter, and there's an appendix at the back which reviews relevant recommendations from the past and talks about whether or not any action happened as a result. Thank you.
Thank you so much, Lita. That was really information-filled, and I'm looking forward to your webinar, February. We are out of time, or we're running out of time, but very quickly, if we have a question. The question is, has the NIH-NGRI working group reached out to you regarding their recommendations that are due out in December?
That's a great question. There has been coordination, but they're very separate, so there is almost no conflict of interest. We actually have almost no overlap between our committee members and that working group, but we have had a chance to brief them on the recommendations. So thank you so much.
Thank you. We're going to move on to our next speaker. I'd like to introduce Ashley Baird, who's a Senior Program Officer for the Committee on Women in Sciences, Engineering, and Medicine. She's going to be talking on her report, the integration of the humanities and arts, sciences, engineering, and medicine, and higher education branches from the same tree.
Thanks so much, and a big thanks to AAMC and FASEB for holding this webinar today and giving us a chance to talk about this important work. So this report, which actually came out under the auspices of the Board on Higher Education and Workforce, moving a little bit too fast there. I wanted to start by explaining the title of this report. So the report was looking at what we see, this trend we see in higher education today at many institutions, all different institution types, everything from community colleges to Research One universities, towards a greater, more intentional integration of the arts and humanities with science, engineering, and medicine. And we see this trend happening in response to a notion we hear often that higher education is becoming too segregated along disciplinary lines. So this idea that higher education has become very siloed. And so the title of the report, Branches from the Same Tree, comes from an Einstein quote. Einstein was quoted as saying that all religions, arts, and sciences are branches from the same tree. This sort of gets at this notion that ultimately all human knowledge and inquiry is fundamentally connected. And the committee really liked this, bringing Einstein into the picture here, because Alex, in her introduction, mentioned the Einstein statue that sits out front of the National Academies building. And in a way, Einstein is sort of the patron saint of the National Academies. So this ties in with this history of the National Academies. So the the study was chaired by Dr. David Skorton, who was previously the president of Cornell and is the current secretary of the Smithsonian Institution. He's also a cardiologist by training and a musician. And so in many ways, he embodies what this report is about. He was the sort of ideal person to lead the committee. And our statement of task asked us to examine the impact of these integrative educational experiences on students. So our real focus was on student outcomes. So the exact language of the statement of task was to examine the evidence behind the assertion that educational programs that mutually integrate learning experiences in the humanities and arts with science, technology, engineering, mathematics, and medicine lead to improved educational and career outcomes for undergraduate and graduate students. And I want to emphasize the mutual in that statement of task. So we were thinking not only about how integration of the arts and humanities into STEM and medical education may benefit students, but also how the integration of science, engineering, and medicine into arts and humanities education could benefit those students that pursue those disciplines, or really any career. We have to acknowledge the sponsors. None of our studies would be possible without the generous funding from external sources. The sponsors for this report are the Andrew Mellon Foundation, the National Endowment for the Arts, the National Endowment for the Humanities, and actually the National Academies. We don't have very much money, but we have some small money, and I think it's a testament to the institution's commitment to this study that our Keck Futures National Academies fund kicked in to support this study. So just briefly, I want to tell you about some of the key findings. The findings were really interesting. So the committee spent 2 years looking at the existing evidence on student outcomes related to these very intentional integrative approaches in higher ed. And I should say that what we're talking about, it goes beyond sort of general education requirements in which a student would take a history class over here and maybe an engineering class over there and a philosophy class over there, to actually integrating the content and pedagogies from that philosophy class in the context of the engineering class. So it's going one step beyond your sort of standard general education requirements. And so when we examined these programs, we found these interesting outcomes that related to improved written and oral communication skills, teamwork skills, ethical decision making, critical thinking, and the ability to apply knowledge in real world settings. And what was so interesting about this, besides the fact that these are very interesting and positive educational outcomes, we also find that these are educational outcomes that we hear increasingly that employers are asking for. So in the report, we reviewed several different sources of evidence, different surveys of employers, in which employers say, yes, the technical skills are important, but they're not enough. And what we feel like students are missing when they leave higher education are these broad competencies. And these happen to be the competencies we found associated with those integrative approaches that have been studied. We also, interestingly enough, found that, and this is not that surprising, but these are also learning outcomes that institutions of higher education, broadly speaking, say these are essential learning outcomes we want all students to leave higher education in possession of. And you can look across a wide array of different institutions to find similar messaging about what students should be getting out of higher education. So just an interesting alignment between what we hear from employers and what we hear from higher education, which so often we hear people talking about this issue like employers and institutions of higher education are asking for very, very different things. And that's probably true in many instances, but we found this interesting this finding that that there is more alignment than people might assume at face value. And so we looked throughout science, engineering, and medicine. I wanted to pull out some findings related to medical education. We found that humanities and medicine programs are actually quite common in medical schools, and there have been some studies that have shown some real positive impacts of integrating the arts and humanities with medical training. And some of those outcomes included increased empathy, resilience, teamwork, improved visual diagnostic skills, increased tolerance for ambiguity, and increased interest in communication skills, so an increased understanding of the importance of strong communication skills. Now moving on to some of the key recommendations. I will say that this first recommendation is really the overarching recommendation made by the committee, which is basically that after they looked at these programs, they examined the sort of rationale for why these programs exist and why there's this movement in higher education, and the available evidence, which we are very upfront in the report. More research is absolutely needed. The available evidence is sparse. But it is compelling enough that the committee felt very confident urging the support and evaluation of courses and programs that integrate the arts and humanities with science, technology, engineering, math, and medicine in higher education. So, after looking at everything that they looked at, the conclusion was, yes, higher ed should consider continuing to experiment with these models, and in doing so, evaluate them. Also, we know that a lot of these programs already exist on campuses. So another recommendation is to say, okay, what's going on your campus, and what kind of impact is it having on students, and how is it possible that it exists? I mean, we know there are lots of barriers to integrating across disciplines in higher education, but the existence of these programs demonstrate that those barriers it's possible to overcome them. So the committee recommended that institutions look at the existing programs to better understand ways to overcome or get around barriers, I suppose you could say. And we also, the committee also felt that the general education requirements are one part of the curriculum that institutions should really think about, because most institutions do have general education requirements. So they do uphold this notion that higher education should provide students with a breadth of knowledge in different, different forms of human inquiry. This is sort of core to most institutions. So given that we already have this, maybe it's time to re-examine how we do higher education, and maybe there's a role for a more integrative approach there. And then getting again to this general education point, the committee recommended that new designs for general education think about integration of disciplines at multiple levels, thinking interdisciplinary, multidisciplinary, and transdisciplinary. But then also to think about how these approaches could apply throughout a student's time in college. So not only during the time in their 4 years or 2 years, depending on the program, when they're doing general education, but how does it integrate with the rest of their studies, and how does it integrate with the major and the specialized learning that they ultimately pursue? So I'm going to end there. I know we're getting close on time, but I will just say I'm actually calling into this webinar from the University of Wisconsin, where we are having a town hall meeting on this report, asking for input and helping facilitate a conversation about implementing the report's findings and recommendations, and promoting strategies for how you might integrate across disciplines in higher ed. And so for anyone on this webinar that's interested in engaging this kind of conversation on their campus, I hope you'll reach out, because we would love to come visit you as well. But I'll stop there, since I know we're getting short on time.
Well, thank you, Dr. Baer. So these reports are full of so much information, and I can't wait for the 1-hour reports coming through the next 5 months. So we'll take a look at our final report now, a hot topic nowadays. It's the report on sexual harassment of women in science, climate, culture, and consequence in the academic sciences, engineering, and medicine. And Dr. Fraser Benya will be leading us with a brief overview of this. Her webinar will be on April 15th, 2019, so you can come to hear more. We're not going to take very many questions after this due to the time. So Dr. Benya, take it away for us.
Thank you, and I'll just second my colleagues' thanks to everyone for organizing this event, and given our time constraints, I'll leave it there. As mentioned earlier, this is the report, Sexual Harassment of Women, Climate, Culture, and Consequences in Academic Sciences, Engineering, and Medicine. I'll go over briefly the statement of task. There were 3 main things it was charged with. First, to review the extent of sexual harassment that is experienced by women in these fields. And then second, how it impacts the recruitment, retention, and advancement of women. And thirdly, essentially, what can we do about it? What can we do to address and then prevent sexual harassment? I also want to acknowledge the many funders that we had for this work. The National Science Foundation served as the lead sponsor, and we also had support from a number of private foundations and federal agencies. So to go over very briefly the major findings and recommendations from the report, this is sort of the very high level of what the report said. There's a lot more detail in the over 300-page report. So first, the committee found that it's very important that institutions pay increased attention to and enact policies that cover gender harassment. This is one of 3 types of sexual harassment, and it can have as severe psychological and professional impacts as the other 2 types of sexual harassment. So the committee made this recommendation based not only on that, but also the fact that gender harassment is the most common form of sexual harassment. Second, the committee found that the cumulative effect of sexual harassment is significant damage to the research enterprise, and this was in reference both to the effect on research integrity and to the costly loss of talent that is driven out of these fields. Third, that the legal system alone is not an adequate mechanism for reducing or preventing sexual harassment. In fact, the committee found that existing mechanisms and the compliance-based approach institutions have been taking has not resulted in any reduction of sexual harassment. Finally, though, the good news is that the committee found that there are ways to effectively address and prevent sexual harassment. It involves making system-wide changes to the culture and climate in these institutions. And the report goes into great detail about what sorts of changes would need to be made to affect the culture and climate. They gave recommendations specific to academic institutions, but also to policymakers, federal agencies, and policymakers. So I'm going to end there. That's the very quick version, and I'll pass things back.
Thank you, Fraser. Unfortunately, we are running already over time, so we don't have any time for any more questions. These reports are so packed with information, it's hard to get it all out in just a few minutes. So, but we are still interested in the last couple of minutes. If you want to enter any questions or thoughts, hopefully we can address them in the future webinars. I'd like to thank our speakers. Really great reports and great presentations, and we look forward to hearing more in your individual webinars. And we encourage all of our participants to register for our webinars on the reports. And again, the webinars will be very focused on how you might be able to implement the report recommendations at your institutions, and that they will be interactive webinars. So please join us for those. And that's it.
Thank you.
Thank you.
Thank you.
Great. Thank you. So with that, we will conclude today's program. Please give us your feedback on today's presentation by clicking on the webinar evaluation link in the links box on the left-hand side of your screen, or by filling it out in the box that pops up on your screen momentarily. This session has been recorded and will be available within 3 to 5 business days. You may access the recorded archive by using the same login information that you used for today's live webinar. On behalf of the Association of American Medical Colleges, thank you to our speakers, and of course, thanks to all of today's participants. Have a great afternoon, and you may now disconnect.